The researchers in England who are working on developing this method or procedure state that they believe they can achieve the results of that they're looking for of remineralizing caries or cavities, demineralized areas of tooth enamel in 15 to 30 minutes. But their method, they emphasize the importance of proper surface preparation. And I'm hoping that even if I can't accomplish as the surface preparation to the degree that they do, that I can obtain acceptable results by doing the procedure for a longer period of time or more often. Since I'm doing it at home, I have that luxury. Whereas in a dental office, this procedure, they're going to want to be able to do it fairly quickly. The coil of the relay is driven by this transistor, and this is the relay that it's being driven. And this is the current source, so I can set the current level. And what I do is when I flop using the relay, I alternate every minute. The polarity alternates, which is something that they say here is what they say to do. So I'll look at the unit that I made. It's just a little circuit board. I got the circuit board off of Banggood. You get the whole package of like 40 of these different size circuit boards. Now that Radio Shack isn't around, I had to go that route. It takes a while to get them though, because they come all the way from China. They're nice though. They're really nicely built. And then I wired it up using that schematic. Okay, so then I connect it. Can't see it. I use one of my free Harbor Freight multimeters. I set it on current mode, so I'm monitoring the current when I do this. That is connected to, let me close up my notes here. This is my one electrode, and what I do is I just wet my hand and hold this, either my right hand or my left hand, and the other hand, I hold this thing, and I just let the solution drain out, and I can usually get, I've been seeing 13 microamps of current. It seems funny because I'll have a different current level depending on the polarity, and I'm not sure if that's a problem with my setup or maybe one of these connections. I mean, this is just a Harbor Freight clip that I soldered onto this end of this piece of wire and clipped on this piece of aluminum foil because I didn't have anything else at the time when I did this. My power supply is just a wall wart. Now I don't suggest ever using one of these. I would suggest using a battery. 9-volt battery. A 9-volt battery might not last very long, so I might try to use some D cells. But I didn't have a holder, and I wanted to get going on this, so I did this. But I made sure that this adapter was completely isolated from the AC mains power, because you're working around. You're spraying. You're conducting current into your body from this, so I'm a little bit leery of this, but I think I did my homework on it. But I would really recommend using batteries. I hope this is helpful, and I would hope that anybody that has any suggestions on better ways of doing this could leave a comment. And one of my main questions is the concentration of calcium and phosphorus dissolved into this water, is that sufficient for the iontophoresis process? In other words, am I actually drawing calcium and phosphorus out of my teeth if I don't have a high enough concentration? I don't know. I'm hoping that that is high enough. Another option that I think I'll mention is I made up another probe here. And what I hope to do with this guy is chew up some of this gum and jam it into the areas that I think need attention. So the calcium phosphate, the CPP, ACP in here would be the reservoir that I needed. And this would then become the other electrode. It would replace, of course, this one. This is a stream of liquid coming out. So this would be just a glob of gum. And then I'd stick this thing up against it. I haven't really done much with that yet. I've been playing with it and trying to decide whether I want to do that. If the voltage is too high, you can feel it. I can tell you that. Try taking a 9-volt battery and touching it to your tongue. You'll know what I'm talking about. Okay, that's all I have for now. I should spend some more time talking about the circuit that I use. The power supply section, which is here, I use 9 volts. Originally I had 6 volts, but you need at least, I think it's 1.2 volts between the input and the output for the voltage regulator to stay in regulation. So since my output is 5 volts, I'm using a 7805, I need probably 6.2 volts, and a 6-volt battery just wasn't enough, so I had to go up to something larger, higher. And what I happen to have is a AC adapter, which, as I said, I don't recommend using an AC adapter. I recommend using batteries, but I don't have any battery holder for this at the time. I'm using a 9-volt input, so that's well over the 6 volts. So I think you need like 7.5 volts. I think the coil for the relay, which is this guy here, is rated for 5 volts. So that is one of the reasons why I use 5 volts here. The transistors, of course, and this flip-flop and the timer chip, they all can handle, I think, up to 15 volts. You have to check the spec sheets. So I could have gone up to a higher voltage, but I don't think I need it. One of the reasons why you might want a higher voltage is because when you set the current here, the current is set. Basically, the current is the current through this resistor, and that current is set by the voltage between the base and the emitter, and there is a 0.65 volt drop between these 2 points, and so whatever this voltage is here, you go up 0.65 volts, and the current is 5 volts minus whatever that voltage is, and that sets your current through the transistor. I have it set, I think right now I have it set to about 3 microamps, and to drive 3 microamps through a very large resistance, of course, the voltage would have to rise. If you only have 5 volts here to begin with, or actually it's going to be actually this voltage here. Anyways, if you don't have enough voltage here, then the collector voltage may not rise to a level that will push the required current through the resistance. And the resistance can vary, of course, because it's a stream of water, or if you're using some kind of like I was going to try using the gum, maybe the conductivity of that is not so good. There's nothing special about the particular transistors I used. I don't remember what this transistor is. It's a part I had on hand. This transistor here, I don't remember what that is either. But it's just these are parts that I had on hand, and they seem to work. A wide variety of parts can be used as long as they can handle the voltage and current. The resistances are, again, mostly parts that I had on hand, and I modified the design to fit what I had. The same with the diodes. The relay was purchased. I don't remember the model number of that, but it's just a small relay. It doesn't have to. It's a double pole, double throw, and it doesn't require a lot of current to actuate the coil, which I have over here. I call it K1. It is, I think, 30 milliamps. So when this is not on, when the relay is not actuated, the current draw into everything is maybe 3 or 4 milliamps. When this turns on, it goes up to 35 milliamps. So it's one of the reasons I wanted to use a fairly large current source for my power supply, or something that can handle a lot more current. That's why I don't think AA batteries would be a good idea. They would probably go bad real quick. And this is the CMOS version. I think I have listed as a 7555. It's the CMOS version of the venerable 555 IC chimer. I think there another part number is the TLC 555 from Texas Instruments. It is this is a CMOS version. This configuration gives you a 50% duty cycle out, and the CMOS version also allows you to just use the one single resistor and the capacitor as your timing circuit, or timing elements, and you can use a lot larger resistor and a lot larger capacitor with this IC. But whatever the output of this is, I reduced the frequency by a factor of 4. So with these two flip-flops, so this might be every 15 seconds it changes state, and this output here will be every minute it changes state from positive to negative. This is just an XY connection. All right. Oh, the probe that I showed earlier, which I don't have it here at the moment, it is simply a piece of stainless steel wire, and I have a plastic sleeve that I found to fit over the top. This plastic sleeve is actually one of those red straws that you get on like a can of WD-40. However, it has never been used, so it doesn't have any WD-40 on it, so I don't recommend ever using one of those plastic straws. It actually has been used because, well, you get WD-40 in your mouth. Okay, that's all I have for now.